Okay, heat transfer. Topic 11.
Yep.
You have conduction, convection, radiation, and global warming. Related lah. They are all related. Okay, introduction. Page 279 in your book. Heat can be transferred by three different process. Conduction. Conduction is usually a solid. There's a solid there. Conduction. Convection, where you feel the heat there from the fire, and then radiation by electromagnetic radiation. Okay? Different from this one. This one is the air, hot air moving up. You can feel it. This one is not the hot air. This is due to electromagnetic radiation. Okay, conduction, number 5 in your note. Transfer of heat energy from the hot end of the material. This is the hot end where you heat up. There's the cold end. To the cold end without. The thing to remember is the material doesn't move. The heat energy move from the hot end to the cold end. Material doesn't move.
Back again. So the heat only move, but the material doesn't move.
Yeah, the heat move only. Material
okay, so that's conduction lah.
Page 304, convection. Here, the material medium move to transfer the heat. The sun heats up the road or the land. Land become hot. It heats up the air. Air become warm. So that material medium in this case is the air. Move to transfer the heat. So the warm air being lighter move up, and then the cold air, which is at top there, cooler one, heavier, sink down and take over the place. That's how it's convection. As warm air rises and cold sink. Okay.
Wait. Material medium moves to transfer the heat as warm air rises and cold air sinks.
In this case, the material medium is the warm air. The air is moving.
But this one is memang fixed lah. There's like no reason to why, right?
Oh, got reason why? Got no reason. The warm air, you heat it up, you expand. This is your SPM work.
Oh yeah. Oh, so in the night means then the cold air will be hot, the warm air will be energy. I mean, what is that?
Okay, you just listen. You are a bit confused. Okay, page 305, radiation. There's the sun. Thermal radiation process by which energy is in the form of electromagnetic radiation. This electromagnetic radiation is emitted by the heated surface. In this case, the heated surface is your sun. It gives out the electromagnetic radiation in all directions. And this is the radiation that travels to the earth or to us at the speed of light. That means very fast. Thermal radiation does not require a medium. You don't need the air. It can travel from the sun through vacuum to the earth. Okay? Key is electromagnetic radiation, and that electromagnetic radiation move at the speed of light. You don't need a medium for radiation. Okay, conduction, page 280.
Back again,
Back to where?
Before that, I may want to ask some question. Okay. No, I was reading it. I just wanted to understand and ask.
Right? The key is electromagnetic radiation
Wait,
emitted
so
by
so thermal radiation doesn't need a medium at all lah in the
doesn't
first
need a
place.
medium. Any hot body, even yourself also emit radiation. But yours
Or
is
also emit radiation lah.
yours is in infrared. I also emit infrared. The table
So
also
the
emit infrared.
thermal, it's been
Thermal is just
emitted
a
by
heat.
the sun lah.
Yeah. Usually the hot got
Oh,
give up more energy.
thermal energy radiates through air from a fire. Oh yeah, then only the radiation reaches to us, right?
Yeah.
Or like that. Okay, okay.
Tiles and carpet. This one is more obvious in the Western country lah, where they have winter. The
Autumn,
tile will be
summer.
cold. Ours you can feel it lah, but we hardly use carpet lah. And then some houses also start to use carpet. They can feel it lah. Carpet will be warm. Tile will be cold in the morning. Right? Bathroom tile colder than carpet. Why? Because tile and stone conduct heat more rapidly than carpet and fabric. Well, your cloth doesn't conduct heat that well. So what causes
Back again. Wait, so tile and stone only conduct heat more rapidly than carpet or fabric. Now about bathroom tile then, teacher.
bathroom tile? It's just the floor. The problem
Bathroom tile is doesn't get that hot, only gets colder,
in morning
right?
you touch the floor, it's cold lah. Just like your floor. Right? If it's not carpeted, you morning walk on it, it's cold. Even
So
though outside
no. But I want to ask, won't it be conducting heat more rapidly also?
yeah. It conduct heat rapidly away. That's why it's cold. Carpet no doesn't conduct insulator. Okay.
Carpet no lah. Okay.
You can touch yourself carpet your clothing. You touch your clothing morning is still very warm, not that cold.
Okay.
Right? What causes conduction in solid? Page 279, number 1. Right? The atoms are closely packed, they are close together, held by strong bond. When you heat the solid, the atoms at the hot end, right, where you heat it, there's a hot end, it vibrates vigorously. So the vibration of the atom set up waves. Right? Vibration causes waves that are transferred across the solid. So the wave move across the solid. Vibration larger, wave larger. The wave are scattered by atoms or dislocation in solid. Conduction by vibration is the sole method of heat transfer in insulator. So in insulator, that's the only way the heat is transferred from the hot end to the cold end by vibration. And this is a slow process, very slow. Okay.
So 1 minute.
The vibration atom set up the waves. The wave is the one that moves from the
The
hot.
conduction or vibration is the sole method of heat transfer in an insulator. Only vibration only lah can do the
Only
heat
vibration
transfer
in
in
insulator
insulator.
that transfer the heat energy.
Oh, only for an insulator you need a vibration of the what is that?
Vibration of the
Yeah lah,
atoms.
you need the vibration of the atoms lah for heat. Okay.
Right? But conductor is different or metal is different, number 6, right? You got free electron. The electron behave like the gas in the room. Right? Good conductor of electricity, example metal, copper, aluminium, gold, silver are good heat conductor also. Right? If it's good conductor of electricity, it's also a good conductor of heat. Whereas insulator of electricity, right? Insulator of electricity are wood, plastic, or non-conductors are also poor heat conductor. In metal, heat is conducted by vibration of atoms and vibration of atoms, anything, whether it's metal or whether it's insulator. But in metal, there's the free electron. The free electron is given kinetic energy when you heat it up. Okay?
Okay.
So the electron
Teacher, back again, sir.
is the key is the free electron. The free electron, okay, when you hit the end,
That's the keyword lah.
the free electron receive the kinetic energy. So it diffuse.
Free electron receive kinetic energy.
From where you heat it up, the free electron will receive kinetic energy. So at the hot end of the metal, electron have more energy. That means more kinetic energy. This electron carry the energy by diffusion. Right? It collide, it move from the hot end to the cold end. So when it collide, right? Remember these are the electron. The yellow one is the electron. These are the ion, right? The atom, the ion there is vibrating. So the electron will collide with this ion, and then kinetic energy will be transferred to this ion. So the ion will vibrate faster. That's how the energy is transferred from the hot end to the cold end. And then remember, the electron move with a greater speed. Okay with that?
Okay. Wait. When electron collide with the metal ion, energy is transferred to the ions.
Key is the metal ion is vibrating. Then
Yes.
the electron is moving in a straight line. And then when the ion block its path, it collide with ion. So the ion will gain kinetic energy. The electron will lose kinetic energy. That's all. Then it will be deflected.
Wait. So the ion will, sorry, I mean the electron will lose kinetic energy lah.
Yeah, collide. When it collide, one will lose, one will gain.
Okay. So electron loss lah. Okay. All right.
Right? We have used the same idea as what you study in your SPM, Bernoulli principle, right? Where you, in this case, is the water that's flowing. So the end nearer where the water start has higher pressure. The end towards the end will be lowest pressure. So it's the pressure that push the water to move. Right? That's your SPM work, pressure gradient. There's a pressure different at different part that cause the water to flow. Okay, but in metal, it's different. In metal, it's temperature gradient, not pressure gradient. No. It's temperature gradient. Temperature is different at different part, so that cause the heat to flow. Right? Bernoulli principle is the water that flow. Whereas when it comes conduction, is the heat that flow. Right? Just to relate to your SPM, that's all. No need to worry about that. So let's look at some definition. Number 4, temperature gradient. That's your material. Right? That's your solid. Thickness. That's your thickness. Right? Delta X. Thickness of material. P. Rate of heat flow or dq dt. So the hot end You heat it up, there's a rate of heat flow. You supply the heat, then it comes out the material. So the hot end, where you heat up is theta1, temperature on entering the material. T2 is the temperature on leaving the material. So theta1 is greater than theta2. So theta1 minus theta2 is called the difference in temperature, or the temperature difference. Okay? You can call it T if you want.
Temperature on leaving and then temperature of on entering and then temperature on
Yeah. The
leaving.
hot end is
Oh
where the
yeah,
heat comes in.
oh yeah lah, it actually enters and then it leaves. So yeah, okay lah, theta 1 minus theta. Isn't it theta 2 minus theta 1?
No, theta1 is higher temperature.
Ah, okay.
Okay, 10 minutes time, we have to change another Zoom already.
Okay.
Right? We introduce a term called temperature gradient. Right? Temperature gradient. Negative shows that the temperature decreases with distance. Right? We add an extra negative sign there. Right? Just to show that as you increase with distance, the temperature goes down. That's all. Unit Kelvin per meter or degrees Celsius per meter, same thing. Rate of heat flow, normal, right? Perpendicular surface is proportional to cross-sectional area material. There's the cross-sectional area, this area. This area is called the cross-sectional area. Temperature gradient, G. Right? So if you like, you can remember the formula as P equals to minus K AG. K is called the thermal conductivity of the material. Okay with that?
Wait, K is a constant called the thermal conductivity and it depends on the cross-sectional area and the temperature. Okay.
Right? Number 6 in your note, thermal conductivity can be defined as the rate of heat flow per unit cross-sectional area per unit temperature gradient. That means you just rewrite the formula as, right? That's your defined as the rate of heat flow. That's the heat flow per unit cross-sectional area per unit temperature gradient. That's all. That's what it means. Right? Unit for power is watt. Area is meter square. Temperature gradient is Kelvin per meter. Right? Simplify it. You got watt. That one per meter, 10 per Kelvin. That's the unit. Not need to memorize it, know how to get it. Okay.
So that's the formula and then work it out only lah.
Mm.
We actually put the negative there because of the temperature, right?
Negative there just to indicate that as the distance increases, the temperature decreases. So you don't need to worry about all the negative sign there in your calculation.
But is the negative sign included for the number, Acha, when finding the answer? No, right?
No, so don't have to worry about the negative sign. Just know how to use the formula. And then this one usually will be given you, right? Thermal conductivity, your textbook will give you, your book will give you, right? Different value. Thing to observe is metal. Example will be your copper or diamond, right? It has high thermal conductivity, right? Air or insulator, styrofoam, the white material in your, when you buy a TV, you see the white material as a styrofoam, right? It got low thermal conductivity. Why? Why air? Air is a poor thermal conductor because air, the molecules are far apart. And collision between molecules allow the transfer of energy. It's far apart.
Diamond, the object is so small, the molecules are like
Diamond is
almost
like
together.
metal.
That's why, right?
Diamond is like
Yeah.
metal. So air, the number of molecules per unit volume is also very low. That's why the thermal conductivity is low.
Hey, did you see the one? The air, the temperature is 25 and copper is 18.05. Isn't it copper supposed to increase also?
You won't worry about this temperature. This temperature tells us
Oh.
at this temperature, I measure the conductivity. So don't worry about this temperature. That means conductivity.
Okay.
Huh? Don't worry about the temperature. Last column is not important.
Okay, Jeff.
Okay, page 281. There's your insulator, or we call it lagging. There's your rod, conductor, temperature T1, theta 1, temperature theta 2. Right? Perfectly insulated. No heat is lost from the side. Graph of temperature against length is a straight line. And then temperature gradient, remember temperature gradient, we just take the temperature, difference temperature divided by the length of the rod. That's all. So it goes in, the heat goes in, it just flow out, nothing is lost, so it goes straight through. That's why separating the light.
But the insulators are below what and above.
The insulator is to prevent the heat flowing out. So the heat goes straight. The line show you how the heat flow. Same like your Bernoulli principle is the water that flow, but in this case it's the heat that flow.
Insulator is to prevent from heat going out.
So the temperature versus length is a straight line, that's all.
All right.
Okay.
Before you change, I just want to see the graph of temperature along the rod against length is a straight line. So yeah, that means they are like
Memorize.
inversely proportional to each other lah.
Memorize, that's all.
And theta
Temperature
1 minus
decreases.
theta 2 over L lah. This one is the y equals to mx thing lah. Okay. Yeah. Okay. Next one.
Okay, we start a new Zoom. You can take about 5 minutes break.
All right. Okay, Thank you.